Right now, somewhere above you, a world hangs in the dark. It has no weather, no wind, no sound, and yet it is not dead. It breathes in ways we are only beginning to understand. It keeps secrets older than any ocean, any mountain, any species that has ever walked this earth. We think we know it. We've stared at it for 200,000 years. We've sent 12 people to walk its surface. We brought home nearly 400 kilograms of its rock. And still, it refuses to give everything up. This is the moon. And tonight, we go deeper. Every night you look at the moon, you see exactly the same face. The same craters, the same dark plains, the Maria, the ancient seas that aren't seas at all, but frozen rivers of volcanic rock. The same expression it has worn since the first human looked up in wonder. This is not a coincidence. This is physics, elegant, relentless physics, doing something called tidal locking. The moon's revolution cycle is the same as its rotation cycle, so the same side always faces Earth. Imagine a dancer who spins at exactly the same speed as she walks in a circle. Her partner always sees only her face. That is the moon, Earth's eternal dance partner. For most of human history, what lay on the other side was the greatest mystery in the night sky. People imagined it was lush, or metallic, or hidden. Some thought gods lived there. Others imagined a civilization that had been deliberately hiding from us for millennia. Then on October 7, 1959, the Soviet spacecraft Luna 3 swung around the far side and took the first photographs. The images were blurry, grainy, barely recognizable, but they revealed something shocking. The far side has hardly any of the large lava seas, called Maria, we see on the near side, and is dominated instead by impact craters. It looked nothing like the face we had always seen. It was rougher, wilder, more ancient looking, a completely different world. The question that has haunted planetary scientists ever since: why? The moon shows us two dramatically different sides, the near side filled with dark volcanic plains, and the far side dominated by bright highlands. This stark asymmetry in crustal thickness and volcanic activity has persisted for billions of years, and scientists still cannot fully explain why. For decades, this was one of those frustrating mysteries, well-known, endlessly debated, but stubbornly unsolved. Then in the summer of 2025, something remarkable happened. China's Chang'e 6 mission, the first ever to return samples directly from the far side of the moon, delivered rocks to Earth that had never been touched by human hands. Scientists around the world tore into them, and what they found changed everything. Rock samples from the moon's far side show it cooled at lower temperatures than the near side, hinting at an ancient heat imbalance. The discovery deepens the mystery of why the moon's two faces are so different. In other words, the far side is colder, not just on the surface, but deep inside. The mantle beneath the far side appears to have always been cooler, always contained fewer heat-producing radioactive elements. Chinese scientists precisely determined for the first time that the South Pole Aitken Basin, the enormous impact crater dominating the far side, formed 4.25 billion years ago, providing a more accurate anchor point for studying the history of large-scale impacts in the early solar system. Think about what that means. 4.25 billion years ago, before complex life existed on Earth, before the oceans settled into their final form, something enormous slammed into this side of the moon with enough force to leave a wound over 2,500 kilometers wide. It may have stripped heat-producing elements away from the far side and flung them toward the near side. And that asymmetry has defined the moon's geology ever since. The two-faced moon has a scar, and that scar shaped everything. Here is something most people don't know. The moon shakes. Not violently, not like the earthquakes that collapse buildings, but it shakes, regularly, deeply, mysteriously, and scientists are only beginning to understand what that means. Apollo-era seismometers installed on the surface measured these shakes from 1969 to 1977. That data showed us that the moon is an active body, a far cry from the stale, lifeless rock many assume it is. We know of several forces that drive these moonquakes: tidal stress from Earth's gravity, thermal expansion as the surface heats and cools, meteorite impacts. But some quakes, the shallow ones, have no obvious explanation. Then in 2025, scientists made a discovery that could alter the future of human exploration on the moon entirely. A recently published study reports that shaking from moonquakes, rather than impacts from meteoroids, was the main force behind the shifting terrain in the Taurus-Littrow Valley, the site of the Apollo 17 landing. Astronauts on that mission had documented boulder tracks and landslides in the area. For decades, scientists assumed these were caused by space rocks striking the surface. Now they know better. The ground itself moved. A fault beneath the valley, an active fault, has been generating quakes for millions of years, and it is still active today. While the danger to short missions is low, long-term lunar bases could face increasing risk, and the findings urge future planners to avoid building near scarps and to prioritize new seismic instruments. And there's more. In February 2026, another study emerged, one that revealed over 1,000 previously unknown tectonic ridges across the moon's dark plains, showing the moon is still contracting and reshaping itself. These features are still forming, meaning the moon's geological story is far from over. The moon we thought was dead is not dead. It is quietly, subtly, persistently alive. And there is something else stirring in its interior, something that should not be there at all: magnetism. Some lunar rocks are surprisingly magnetic despite the moon having no global magnetic field today, suggesting either an ancient lunar dynamo that has since died out or magnetic fields generated by massive impacts. Recent research hints that large impacts might temporarily amplify weak magnetic fields, leaving behind localized magnetic signatures, like fossil compasses. The moon once had a magnetic field. Something, perhaps its molten core churning in the ancient past, generated a planetary shield, just like Earth's. Then it died. But the rocks remember. Locked inside ancient basalt and mineral grains are the frozen fingerprints of a force that no longer exists. Reading those fingerprints is a painstaking task, one being carried out sample by sample, mission by mission. And we must also confront those strange, bright features you may have seen in photographs of the lunar surface. Swirling white patterns, like brushstrokes painted by a cosmic hand. These bright, winding patterns scattered across the moon's surface look like cosmic brushstrokes painted against dark terrain. They appear optically young despite sitting on ancient lunar landscapes, and they perfectly align with mysterious crustal magnetic anomalies. Scientists are still debating whether these form from magnetic shielding, protecting the surface from solar wind, unusual dust transport, or ancient impact events. They are beautiful, they are baffling, and they connect the moon's dead magnetic past to its still unresolved present. Every secret the moon holds points back to one moment, the most violent event in Earth's history. A moment so catastrophic, so total, that it reshaped not just our planet, but the entire future of life. 4.5 billion years ago, the young Earth was struck. Not grazed, not nudged, struck by a body roughly the size of Mars, moving at tens of thousands of kilometers per hour. About 4.5 billion years ago, a colossal impact between the young Earth and a mysterious planetary body called Theia changed everything, reshaping Earth, forming the moon, and scattering clues across the solar system. The energy released was beyond imagining. Rock vaporized, the outer layers of Earth were stripped away. A cloud of superheated debris, molten rock, vapor, and plasma spiraled out into orbit, and from that cloud gravity slowly, patiently gathered matter together, until a world-sized ball of magma coalesced in the dark. That ball became the moon. Scientists used Apollo samples to come up with the strongest existing model, that the moon began as a magma ocean, a giant ball of molten lava orbiting Earth. As it cooled, minerals crystallized. Lighter materials floated to the top, forming the pale highlands. Denser minerals sank, and over hundreds of millions of years, the chaotic glowing sphere solidified into something that looked, to future eyes, like our moon. But the giant impact hypothesis, for all its elegance, has holes. One of the most problematic aspects of the collision model is that scientists have a hard time calculating a scenario where the large impactor Theia hits Earth with just the right amount of force. Too fast, and the debris scatters into space rather than coalescing. Too slow, and there's not enough material ejected to form a moon this size. And then there is the isotopic problem. When scientists compare the chemical fingerprints of Earth rocks and moon rocks, the ratios of specific isotopes like oxygen-17, they find they are almost identical. But if Theia was a separate planet that formed elsewhere in the solar system, its chemistry should be different. Why does the moon look chemically like a piece of Earth, and not like a foreign impactor? No fully satisfying answer exists yet. In November 2025, a new study proposed that scientists may have found the remnants of Theia still inside the Earth, buried deep in the mantle as two enormous blobs of anomalously dense material, one beneath Africa, one beneath the Pacific. These mysterious structures, called LLVPs, large, low-velocity provinces, may be fragments of Theia that never left, embedded in Earth when the collision happened. If true, we carry the body of the Moonmaker inside our own planet to this day. The moon was born from catastrophe, and the catastrophe still sleeps inside the Earth. For a long time, we were certain of one thing about the moon. It was dry. Completely, utterly, irreversibly dry. When Apollo astronauts brought home those first lunar rocks, geologists examined them obsessively. No water, not a molecule. The moon, scientists concluded, was the driest place in the solar system, drier than the driest deserts on Earth by many orders of magnitude. That certainty lasted about 40 years. Then the discoveries started coming. First, hints from radar measurements. Then orbital probes detecting hydrogen at the poles. Then, in 2008, India's Chandrayaan-1 spacecraft confirmed hydroxyl molecules, the molecular building block of water, spread across the lunar surface. In 2009, NASA sent a rocket into the Cabeus crater near the moon's south pole, and the crash kicked up a plume of dust that rose almost 10 miles above the crater's rim. And grains of water ice were part of the cloud, confirming that water exists in permanently shadowed regions near the poles. The moon, we now know, has water. Not lakes, not puddles, but ice. Ancient, hidden, cold beyond imagination, tucked inside craters that have not seen direct sunlight in billions of years. Water signatures appear in permanently shadowed polar craters, on sunlit surfaces, and trapped in ancient volcanic glass. But the deeper question, where did it come from, remains one of the most contested issues in planetary science. The leading theory for a long time was simple. Comets and asteroids delivered it. Researchers think there was a time period when Earth and the moon were being bombarded by comets and asteroids, which contain a lot of water ice, and this might have delivered our own oceans and lakes, as well as the moon's icy deposits. During the late heavy bombardment, that violent period roughly 3.5 billion years ago, when the inner solar system was pummeled relentlessly, water-rich bodies crashed into the moon and left their contents behind. In the cold and dark of polar craters, the ice survived. It waits there still. But that's not the whole story. Tiny glass beads from lunar volcanic eruptions contain surprisingly high amounts of water in their crystal structure, challenging the old idea that the moon formed completely dry. These volcanic deposits suggest the lunar interior once held significant water reserves that erupted to the surface billions of years ago. The moon's inside was wet. The impact that formed the moon didn't destroy all the water. Somewhere deep in the mantle, water molecules survived, trapped in minerals under enormous pressure, eventually escaping through ancient eruptions and being distributed across the surface. And then, the strangest discovery of all. Hydrogen and oxygen ions escaping from Earth's upper atmosphere and combining on the moon could be one of the sources of the known lunar water and ice. For 5 days every month, as the moon passes through the tail of Earth's magnetosphere, it is like the moon is in the shower, a shower of water ions coming back to Earth, falling on the moon's surface. Earth is literally raining water onto the moon. Our planet's own atmospheric gases, guided by magnetic fields, drift outward into space, follow the moon in its orbit, and settle into the lunar soil. Researchers estimated the moon's polar regions could hold up to 3,500 cubic kilometers, roughly the volume of Lake Huron, of surface permafrost or subsurface liquid water created from ions that escaped Earth's atmosphere. A lake's worth of water, sourced from our own sky, sitting frozen on the moon. The moon's water is not just a geological curiosity, it is the key to humanity's future in space. Making high-resolution measurements of the type and amount of lunar water will help us understand the lunar water cycle, and it will provide clues to other questions, like how and when Earth got its water. NASA's Lunar Trailblazer mission, launched in early 2025, is right now mapping the moon's surface water in unprecedented detail. And the ice in those permanently shadowed craters may contain something even more profound, like an ice core from a glacier on Earth that can reveal the ancient history of our planet's atmospheric composition. This pristine lunar ice could provide clues as to where that water came from and how and when it got there. The ice on the moon is a time capsule, and inside it, there may be the story of where life began. One idea for the origin of life is that its building blocks were delivered by comets. There may be remnants of those in the ice on the moon. If so, if organic molecules, amino acids, the chemical precursors of life itself, are locked in the lunar permafrost, then the moon is not just Earth's companion, it is Earth's archive. There is a category of lunar observation so strange, so persistent, so difficult to explain, that scientists gave it a deliberately vague name: transient lunar phenomena. For centuries, literally centuries, astronomers have reported things they shouldn't be seeing: flashes of light, reddish glows, clouds of vapor that appear for minutes, then vanish. In 1178, a group of monks in Canterbury reported watching the crescent moon suddenly appear to throb and writhe, its upper horn splitting in two, then glowing. In the 1960s, observers at multiple telescopes simultaneously reported a reddish event near the crater Alphonsus. NASA took it seriously enough to task its own astronomers with monitoring the surface. For centuries, astronomers have reported seeing brief flashes, glowing patches, and color changes on the moon's surface that vanish as quickly as they appear. These events are real, confirmed by independent observers at separate locations, and in modern times by automated telescope networks. But their cause remains elusive. Some may be meteorite impacts, small rocks from space striking the surface and releasing kinetic energy as light. Some may be outgassing events, pockets of ancient volcanic gas released through cracks in the crust. And some remain genuinely unexplained. The most haunting class of TLPs are those that seem to originate from inside the moon. A geological body we thought was cold and inert occasionally glows, not with the reflected light of the sun, but with something else, something internal. Perhaps the moon is not as quiet as it looks from 384,000 kilometers away. Perhaps its geological heartbeat, slow, ancient, faint, occasionally breaks the surface. When the Apollo astronauts landed on the moon, They expected challenges: radiation, temperature extremes, the physical difficulty of working in a spacesuit. What they did not fully anticipate was the dust. Lunar dust, regolith, is not like any dust on Earth. On Earth, dust particles are worn smooth by wind and water and time. Lunar dust has never experienced any of that. Every grain is sharp, jagged, abrasive, like glass shards at a microscopic scale. It clung to spacesuits. It clogged equipment. It penetrated seals. Astronauts who accidentally inhaled it said it smelled like gunpowder. But there is something even stranger. Apollo astronauts in robotic missions reported a phenomenon that defied easy explanation. Dust appeared to be floating, not rising in clouds from disturbance, but gently, mysteriously levitating above the surface. Apollo astronauts in robotic missions reported seeing faint glows near the lunar horizon and dust fountains rising from the surface, phenomena that might result from electrically charged dust particles levitating in the moon's weak electric field. How? The moon has no wind, no weather, no force that should be lifting fine particles off the ground. But the sun's ultraviolet radiation striking the sunlit surface ejects electrons from the soil, leaving it positively charged. In the shadow just beyond the terminator, the line between light and dark, the ground is negatively charged. At that boundary, an electric field forms, and in that field, charged dust particles can be repelled, lifted, rising in slow, glowing arcs above the surface. The exact mechanism, whether from micrometeorite impacts, solar radiation, or electrostatic forces, isn't fully understood, but it could pose real hazards to future equipment and astronauts. Think about that. The moon has weather. Not atmospheric weather, but electric weather. A planet-wide electromagnetic phenomenon that causes its soil to float. For future lunar colonists, this is not a poetic curiosity. It is an engineering problem of the highest order. Dust in lungs, dust in instruments, dust in solar panels, slowly killing them. The moon's most silent secret may be its most dangerous. If there is one place on the moon that holds the greatest concentration of secrets and the greatest promise for humanity's future, it is here, the South Pole. Stand at the right spot on the rim of Shackleton Crater at the lunar South Pole, and you would be in permanent sunlight. The sun never sets. It circles the horizon in a perpetual low arc, bathing certain ridges and peaks in unbroken daylight, a solar energy source that never turns off. It is one of the most valuable pieces of real estate in the solar system. But step into the crater itself, step into the shadow, and you enter one of the most extreme environments imaginable. Ancient ice is hidden deep in permanently shadowed craters. Some of these craters have not seen a single photon of direct sunlight in over 2 billion years. Inside them, temperatures plunge to minus 250 degrees Celsius, colder than Pluto's surface. And inside them, under the frozen soil, may lie something extraordinary: ice. Ancient, pristine, undisturbed ice. Not just water ice. Scientists believe these permanent cold traps have captured a variety of volatile compounds over billions of years: carbon dioxide, ammonia, methane, and perhaps complex organic molecules, the chemical vocabulary of life itself. The moon's South Pole hides a 4-billion-year-old secret. A colossal northern asteroid impact billions of years ago likely shaped the moon's south polar region and explains its uneven terrain. Researchers found that the South Pole Aitken Basin formed from this ancient catastrophe. In other words, the South Pole's extraordinary topography, its craters, its permanent shadows, its strange mix of sunlit ridges and frozen depths, is the direct result of one of the most violent impacts in the moon's history. Violence created the darkness. Darkness preserved the ice. Ice may preserve the story of life. For NASA's Artemis program, which aims to establish a permanent human presence on the moon, The South Pole is the destination. It offers solar energy, potential water for drinking and fuel, and a platform for deep space exploration. But it also offers something harder to quantify, a connection to the deepest past of the solar system. When future astronauts drill into those shadowed crater floors and pull up cores of ancient ice, they will be reading a record that has been sealed for longer than complex life has existed on Earth. One idea for the origin of life is that its building blocks were delivered by comets. There may be remnants of those in the ice on the moon. The South Pole of the moon is not just a base camp, it is a library. There is something on the moon that should not be there, something beautiful, something physics struggles to fully explain, something that was hidden in plain sight for decades and only recently began to give up its secrets. They are called lunar swirls. From orbit, they appear as bright, sweeping patterns, like brushstrokes of pale paint across the gray surface, curving and winding for hundreds of kilometers. They appear on both the near and far sides. They have no obvious relationship to craters or terrain, and they glow, not literally, but optically, their surfaces reflecting more sunlight than the surrounding ground. What makes them truly puzzling is that they appear optically young, despite sitting on ancient lunar landscapes, and they perfectly align with mysterious, crustal, magnetic anomalies. This is the key. Every single lunar swirl sits directly above an anomalous patch of magnetized rock. In a world with no global magnetic field, these localized fields are extraordinary. They are strong enough, in some cases, to partially deflect the solar wind, the continuous stream of charged particles from the sun that bombards the airless lunar surface and darkens it over time. The theory that has gained the most support suggests the swirls are regions where the surface is shielded from this darkening process. Where the magnetic anomaly is strong enough to deflect solar wind, the surface stays bright, young-looking, reflective. Where it isn't, the surface darkens, and the contrast creates the swirl pattern we see from orbit. But that only raises the deeper question. Where did these magnetic anomalies come from? In a world with no dynamo, no molten core churning to generate a global magnetic field, how do patches of magnetized rock appear? One possibility: ancient impacts. A massive meteorite strikes with enough force to generate a temporary plasma field, a cloud of ionized gas that briefly wraps around the impact site. As the rock cools, it freezes the direction of that temporary magnetic field, preserving it like an amber fossil. The magnetic field generator died long ago, but its fingerprints remain. Scientists may have solved the mystery of why the moon shows ancient signs of magnetism, although it has no magnetic field today. An impact could have generated a cloud of ionized particles that briefly enveloped the site. The moon is covered in these fossil memories, memories of collisions, memories of heat, memories of a time when it was magnetically alive. The swirls are not decorations, they are scars, beautiful, luminous, electromagnetic scars left by some of the most violent moments in the moon's past. We have spent this entire journey exploring what the moon keeps secret, but there is one more mystery, quieter, more intimate, perhaps the most important of all. What has the moon done to us? Not to our imagination, not to our mythology, to us, biologically, evolutionarily, existentially. The moon is the great stabilizer of Earth. Without it, our planet's axial tilt would wobble chaotically, ranging from nearly 0 degrees to perhaps 85 degrees over millions of years. At 85 degrees, the poles would face the sun directly for months at a time. The equator would freeze in permanent winter. The climate would swing between extremes that life as we know it could not survive. The moon's gravity, just by being there, just by pulling steadily, keeps Earth's tilt stable between about 22 and 24 degrees. It gives us our seasons, moderate and predictable. It may be one of the reasons life on Earth evolved into the complexity it has. Without the moon, there might be no forests, no oceans teeming with fish, no animals, no civilization, no one to look up at the sky and wonder. The moon also drove the tides, and those tidal pools at the edges of ancient seas may have been the crucibles where life first crossed from ocean to land. Twice a day the tide came in and went out, concentrating chemicals, enabling reactions, drying and wetting the organic compounds at the shore until, through processes we still don't entirely understand, life took its first terrestrial steps. And recently, tiny bits of Earth's atmosphere have been drifting to the moon for billions of years, guided by Earth's magnetic field. We give to the moon gives to us. This is not a one-way relationship. It is a planetary partnership, ancient and ongoing. A co-evolution that began at the moment of catastrophic collision and has continued through every tide, every eclipse, every night the moon hung in the sky above our ancestors' fires. In the months and years ahead, the moon will be busier than it has been since 1972. NASA's Artemis program plans to return humans to the South Pole, and not just for a visit. Lunar bases, lunar ice mining, lunar observatories positioned on the far side of the moon where Earth's radio noise cannot reach, and the deep universe can be heard for the first time in pristine silence. China's Chang program will continue sending missions. India's Chandrayaan series, commercial landers from multiple countries, a new moon race, not driven by Cold War ideology this time, but by science, resources, and the recognition that the moon is the gateway to everything beyond. And with each mission, new secrets will surface. We will finally determine whether the moon's core is solid or liquid, whether its geological heartbeat has truly slowed to nothing, or whether something still moves in its deep interior. A global seismic network installed around the moon would be tremendously helpful in understanding the trigger mechanisms behind all this tectonic activity. We will drill into those permanently shadowed craters and read the frozen record of the solar system's early chemistry. We will map the water, every deposit, every form, every source, and determine whether the moon can support a permanent human presence. We will unravel the magnetic swirls. We will understand the two-faced moon. And perhaps, if we are very lucky, inside the ancient ice of the South Pole, we will find the chemical ancestors of life. The molecules that arrived by comet 4 billion years ago crashed into the moon and were preserved perfectly in the dark, while everything on Earth was recycled again and again by geology and biology until the original record was lost. The moon may hold the answer to the deepest question of all: how did life begin? For 200,000 years, our species has stood beneath the sky and looked at that light. We told stories about it. We organized our calendars by it. We sang to it and prayed to it and navigated the open ocean by it. And in 1969, 12 human beings walked on it, picked up its rocks, left their footprints in its ancient dust, footprints that, with no wind and no rain to erase them, are still there, exactly where they were left, waiting. We think we know the moon, but it is still keeping secrets. Its cold, silent far side has only just begun to speak. Its polar craters have not been touched. Its magnetic ghosts have not been decoded. Its water has not been tasted. Its moonquakes have not been fully mapped. Its ancient ice has not been uncorked. The moon is not a finished story. It is an opening chapter. And the most extraordinary part of this whole adventure, the part that should make you feel something deep in your chest, is this: that pale light you see on a clear night is not just a beautiful sight. It is a library, a time capsule, a geological record of the solar system's violent, creative, improbable beginning. And it has been there, every single night, waiting for us to be curious enough to ask the right questions. We're getting there.